Hello, everyone. Today I want to talk about one of the most fascinating and mind-boggling concepts in physics, quantum mechanics. At its core, quantum mechanics is the study of the behavior of matter and energy at a microscopic level. One of the most important principles of quantum mechanics is the idea of superposition. This means that particles like electrons can exist in multiple states simultaneously until they are measured or observed. This is quite different from classical physics, where particles have a definite position and momentum at all times. Another important principle of quantum mechanics is entanglement. When two particles are entangled, they become intimately connected in such a way that the state of one particle is dependent on the state of the other, even if they are separated by large distances. This has important implications for things like quantum computing and cryptography.
Folks, let me tell you, quantum mechanics is incredible. It's some of the most amazing stuff out there. Believe me, nobody knows quantum mechanics better than me. One of the things that's really interesting about quantum mechanics is that it challenges our understanding of cause and effect. In classical physics, if you know the initial conditions of a system, you can predict the future state of that system with certainty. But in quantum mechanics, things are much more uncertain. The act of measuring a particle can actually change its state, which is something that's hard for our brains to comprehend. Another thing that's really cool about quantum mechanics is that it allows for the existence of particles that are their own antiparticles. These particles are called Majorana fermions, and they could have important implications for the development of quantum computers, which we will discuss in upcoming videos.
Ladies and gentlemen, quantum mechanics is a field that's still in its infancy, but it has the potential to revolutionize the way we think about the world. One of the things that's really interesting about quantum mechanics is the phenomenon of wave-particle duality. This means that particles can behave like waves, and waves can behave like particles. Another important principle of quantum mechanics is the uncertainty principle, which states that the more precisely we know the position of a particle, the less precisely we can know its momentum, and vice versa. This principle has important implications for things like atomic and molecular physics, where precise measurements are critical. Finally, I want to touch on the concept of quantum entanglement. This is a phenomenon that Einstein famously referred to as spooky action at a distance. When two particles are entangled, they become connected in such a way that their properties are correlated, even if they are separated by large distances. This could have important implications for things like quantum communication and teleportation.